We'll proceed in flux calculation across the surface in calculus. Curl calculation is line integral where the flux calculation is surface integral. So flux calculation is surface integral and curl calculation is line integral. If I have a vector field is algebraic vector, a vector whose components are algebraic equation, that is called vector field. So if I have a varying vector, a vector which is varying in its direction and varying its in magnitude, both magnitude and direction variation is guided through algebraic equation, guided through change in independent variable. Like if I have a vector field equal to x plus yi plus x plus sine yj, means first component x plus y will keep changing if I change independent variable x and y. The second component will keep changing if I change the x and y component again. So this is example of vector field. If I have a vector field and if I have a surface, then the surface integral is vector field strength multiplied by the area. So if vector field is the velocity of a water and water is passing through this area, then net surface integration, the surface integral is nothing but what is the volume of water that is coming out of this surface per second. So velocity is meter per second, area is meter square, multiplied meter cube per second. So if I see this as vector and area as vector, then vector dot area, vector, this velocity vector dot area. If this velocity vector is vector field, means it will keep changing, depends upon the xy and its magnitude, and this area is not flat now, it is something like this, then how much is the volume coming out of the full surface? Now it comes as integral calculus, and capital F, that is the velocity vector field, capital F vector dot small d area vector. Now always integral over the full surface. So this is the surface integral, this is flux, this is volume per second coming out of the surface, or rate of flow through the surface, whatever the terminology anyone can use. Before we proceed into divergence or flux density, the biggest threat, capital F vector dot small dA vector, dA vector, capital F vector integration along the full surface. Vector field I know, but if I have a surface, the surface is oriented surface. It's not a Moby wand or something surface. We'll talk about oriented and non-oriented surfaces. So surface is oriented surface, but surface is not flat. If it is flat, then perpendicular to this is the surface direction. Perpendicular to oriented surface means it has two surfaces. This side surface, this side surface. This side surface now perpendicular is this. This side surface, I mean this side surface, the direction of the surface is like this. This side surface, the direction of surface like this. So if vector field is like this and then it is crossing, okay, if it is oriented surface and I am taking back side, then both are in same direction. So dot product will work. If velocity vector is like this and surface is like this, then potential there won't be any flow through the surface, because surface vector is like this and velocity vector is like this. Dot product 90° cos theta is 0. Now question arises is how I can calculate dA vector. dA vector. How I can calculate dA vector. That is a big thing that need to be understood. There are two ways. One way is that you calculate A dA, dA, delta A area you calculate and then multiply it by the kind of unit vector that is normal to the area. This is what we saw in a spherical coordinate system. cylindrical coordinates. So if I have a cylinder, okay, so if I have a cylinder, if I have a cylinder and I want to calculate the dA vector, if this is a cylinder, this side open and it is kept on xy plane, the cylinder is kept on xy plane, and now I want dA vector along the this surface, not base one. Base one is attached to the xy plane. If I want dA along this, I take a small strip here. Okay, what is A? Small strip A. Area has two sides. One side is the this vertical side, and other side is the perimeter. What is perimeter? If this base has a radius r and radius r rotates theta angle, that is 2 pi is the maximum, then what is the perimeter? Arc. If I take a small area here, then height is delta z. What is r? R d theta. So r d theta dz is the area. What is direction of area? Unit vector. So this is radial. If I take radial direction, then it is r cos theta I plus r sin theta j in polar coordinate. Now if I take unit vector, then it becomes cos theta I plus sin theta j. Now this is unit vector. So dA vector is cos theta I plus sin theta j in braces dA. dA unit vector dA. If I take right side, it becomes dA vector. So dA vector is nothing but cos theta I plus sin theta j r d theta dz. So d of, okay, so the normal vector, no, the unit vector dA. So unit vector is cos theta I plus sin theta j, and dA is r d theta dz. Now if I have a vector field capital F, if I have a vector field capital F, then capital F dot cos theta I plus sin theta j dA, not dA vector. So this is the an integration along the cylindrical surface. Or if I take a spherical region, and any delta area, if I calculate, first I have to calculate delta area and then radial unit vector. That is the dA vector or dA vector, delta A vector. So what is the, if I have a sphere, okay, so if I have a sphere and it is centered at the origin, and if I take a small strip here and take out this small strip, now if it is area, then it has two components. One is vertical arc, one is horizontal arc. Vertical arc, if there is a vertices and there is an angle called phi from the vertices, the vertical arc is a d phi, where a, small a, is the radius of the sphere. If this sphere has a constant radius, that is small a, and if I calculate vertical arc, there is two arcs. One is horizontal arc. If this is centered at the origin, then xy plane cut exactly at the half. Where it cuts it, there is a circle. That circle radius is a. But if I move up, 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 and I can make cross section everywhere there is a circle, where radius is variable. Consider that as r. R, where the major radius of the sphere is a. If that is the case, then at any r, what is the arc? R, r d theta. What is the arc vertical? If there is a vertices, and from vertical, there is a phi angle, then it is a, 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 a d phi. So the d area is r d theta a d phi, where r, at any position, if I take r and this is the at that position, so if I cut somewhere and cross section is radius r, and at the end from the center there is a radius, that is sphere radius. Sphere radius is a, and where I made a cross section there it is r, then r, and with vertical it is making angle phi, then r equal to a sine phi. So r d theta means a sine phi d theta, a sine phi d theta, a d phi. that is dA. What is the unit vector, radial vector from the center that is passing through dA? That radial vector, if I see, that radial vector is nothing but the whatever the kind of radial vector we can expect. Okay, so if that point, I have to calculate that point x, y, z, and xi plus yz plus zk divided by square root of x square plus y square plus z square. So x square plus y square plus z square root, that is a, that is the radius a, and xi plus yj plus zk, x component is r cos theta. Here the x component is, if I if this is the center, I cut it. Here radius is a, but if I cut little up, then radius is r. Okay, so r cos theta, r is a sin phi. So a sin phi cos theta I plus a sin phi sin theta j plus z, that is the height, that is a cos phi. Now divided by a, that is the radius. So now it becomes capital F vector, the flux capital F vector dot, capital F vector dot with the unit vector, that is nothing but sin phi cos theta I plus sin phi sin theta j plus cos phi k dA, because vector I have kept outside, dA. So dA is a square sin phi d theta d phi. A square sin phi d theta d phi. Actually, it was r d theta a d phi. R become a sin phi. So a square sin phi d phi d theta, where phi goes from 0 to pi and theta goes 0 to 2 pi. Now this is the surface integral flux, net calculation for the flux. But the biggest dilemma that is seen is the Cartesian coordinate. There we do not have any radial or something like that. Quickly I can calculate the dA. That is the biggest thing, and that is where our fundamental works. So whatever the proof, whatever we are talking about, that is our way. So our way is calculating through the cross product. So cross product in the sense, that if this cross product in the sense that, consider this is an object and it is centered at the origin. Now we are talking about Cartesian coordinate. This is x-axis, this is y-axis, and this is z-axis. This is origin, and this sphere is centered at the origin. So origin is at the center of this sphere. Now I have to calculate dA vector, because flux is capital F vector dot dA vector, integral over full surface. So dA vector is always the most tiresome when we calculate the surface integral. What is dA vector? What is dA vector? Now take any point x, y, z. Then what is the radial vector origin? From origin, if I connect this x, y, z point through radius, then this radial vector is xi plus yj plus zk, where z is dependent component and xy independent component. Mind it, this is very much different to spherical coordinate system and cylindrical coordinate system, where theta r theta and z, or r theta phi, are independent component, looks like. But here z is dependent component. Okay, so there, if I take a spherical coordinate system, any place I take out dA, here there is no question of dA at all. Okay, so what is the question? There is a position vector now. We can use position vector in cylindrical and spherical coordinate system. One example we have seen. Please watch the video. One example we have seen. Now, if this is centered at the origin, from origin, if there is any point P, that point is x, y, z. If I take out any vector, the vector position vector is xi plus yj plus zk. where z is dependent upon x and y. Xy is x on xy plane, x axis, y axis, where z is dependent upon x and y through a algebraic function. Okay, if that is the case, then the gradient of this vector is gradient along x-axis, gradient along y-axis. If p equal to xi plus yj plus zk, this is our proof. You will find very cumbersome, very difficult proof in the book, and that for the God grace who is responsible for that proof. But this is very solid proof. If there is a p vector, 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 then if I calculate gradient of it, then gradient will be perpendicular to it. This perpendicular will form a surface. Can you see? Everywhere it is perpendicular to this vector. That gradient of this vector xi plus yj plus zk is first first we'll calculate gradient with x. So dp by dx is I plus dz by dx k. dp by dy equal to j plus dz by dy k. Now see closely, dp by dx equal to I plus dz by dx k. It has two components, I vector, k vector. I vector, k vector. I vector is constant 1, whereas k vector is dz by dx, dz by dx. If I take a sphere, and if this is x-axis at this point, or along the x-axis at the end point dz by dx, if dz by dx means change in height that is seen when there is 1 unit change along x-axis, that is maximum here. So at this position, if I calculate dp by dx, if this is the position vector dp by dx, I plus dz by dx is infinite. Means dp by dx, the gradient vector is exactly like this. Can you see? It is a kind of tangential. If it x equal to 0, when x equal to 0, the vector is when dz by dx when x equal to a is the radius of the sphere, then it is infinite. When the radius is 0, means along the z axis dz by dx is 0, at that moment dp by dx is I1, means it will be along like this. So it is like this, dz by dx, dz by dx, dz by dx, we are talking about xz plane. If this is x-axis, this is y-axis, this is z-axis, then this is xz plane. This is yz plane. So in xz plane, dp by dx, in xz plane, a story is going on in xz plane. If it is xz plane, then the dp by dx, if this is the gradient vector, then it will have all the dancing in xz plane only. Either it will rotate 360-degree in xz plane only. If I have dp by dx, dp by dy, then it will do all the rotations dancing in yz plane only. Okay. If I, so at any point, if this is the p vector, if this is the p vector, the gradient at any point, one gradient is in xz plane, which has y-axis component and z-axis component. dp by dy, whose gradient in yz plane, which has y-axis component and z-axis component. Okay, so if I keep changing the position, then dp by dx will keep changing like this, whereas dp by dy will keep changing like this in yz plane. Okay, so in yz plane, dp by dy will keep change like this. P is position vector. In xz plane, dp by dx will keep changing like this. So at any position P, any position B, if I have dp by dx and dp by dy, then if these two, if I calculate the cross product, then it will give the exactly the surface area vector. Okay, so if we are at this position on x-axis, we are at the radius position, maximum position. Here, dp by dx is completely like this, okay, and dp by dy is j plus dy dz by dy, dz by dy. Here, the kind of dz by dy, dz by dy, how much y at this position, how much y is changing, whatever it, okay, dz by dy, that y is 0 here. On x-axis, y is 0. Here, if I change y little bit, y will go along this direction. Okay, so y will go along this direction. So it is same as like if I had done here. So dz by dy is 0. Dz by dy would be 0, where dz by dy would be maximum along y-axis. Here, dz by dy would be maximum. Okay. Now here, if I'm so only the factor that will be come into the effect here is dz by dx, that is infinite. Similarly, at every point, if I calculate, then I have two gradients. One is dz by dx, one is dz by dy, whatever it is. So if I do cross product of dz by dx cross dz by dy, at that moment it will change into area vector. If I have two vector, one is in xz plane and another vector is in yz plane. So if it is a sphere, so every moment it will not be in xy plane. The dz by dx will not be in x, will not be along the x-axis. It will be in xz plane somewhere. Dp by dy will not be along the y-axis. It will be somewhere in the dyz plane. Consider it is like this. It is following the yz plane. It is following the xz plane. This proves that at that moment surface is slant. If they are exactly like this, then surface is flat at that moment. It's algebra at the end. If you keep changing x and y, things would change. So dp by dx and dp by dy, if both are along, dp by dx is completely along x-axis, that we can see when dz by dx is 0. dp by dy is completely along y-axis, where we see dz by dy is 0. If that is the case, then cross product will lead into surface vector which is parallel to the xy plane. Its direction will be k. But dz by dx will keep changing in xz plane. dz by dy will keep changing in yz plane. And accordingly, its cross sectional will give area wherever they are. And then the area vector will be perpendicular to this. So area vector will keep changing like this everywhere. Understood, right? So here the area vector is like this. Here area vector is like this. Here area vector is like this. Here area vector is like this. Keep changing. And where the dA is dz by dp by dx cross dp by dy. This is area vector. Area vector, this is area vector. Now area vector we have calculated, but this is gradient. Area vector what we have calculated is gradient. It's not pure area vector. Pure position vector, through position vector I have to calculate the area vector. I did dp by dx, it is called velocity area vector. If from velocity area vector, if I want the actual area vector, I have to integrate along xy plane, mind it. This is not a spherical coordinate system or cylindrical coordinate system where dA we calculated and then we multiplied by unit vector in that direction. It is not the case. Here we calculated the area vector, area velocity vector, and that we integrated along xy plane, and that will come as the displacement area vector. So dz by dx cross product dz by dy, and then dA is xy plane. So Cartesian, so dx dy. So the flux is capital F dot, and in braces dz by dx, dz by dx, dz by dx cross product dz by dy. It will be in vector form. dz by dx I'm sorry, dp by dx. So capital F vector dot dp, position vector, dp by dx, position vector is a vector, dp by dx, that is I plus dz by dx k cross j plus dz by dy k. If I do cross product, it will come as minus dz by dxi minus dz by dyj plus k dA, that is dx dy, capital F vector dot minus dz by dxi minus dz by dyj plus k, bracket close, and then dx dy integral over surface. We have calculated surface area through this. Then what would be the surface area? If I am calculating a positional area vector, not velocity area vector, positional area vector as dp by dx cross product with dp by dy and dA, that is dx dy. If that is the case, then its magnitude will give me the area. So if dp by dx cross dp by dy is minus dz by dxi minus dz by dyk dz by dyj plus k, its magnitude is dz by dx whole square plus dz by dy whole square plus 1 square root dA dx dy. This will give me the surface area. Okay, because magnitude of area vector will give me the surface area. So this is analogous to the 2D also. Here we are calculating 3D in Cartesian coordinate, where z-axis is dependent component upon the two independent component x and y, or z is dependent upon xy plane. Okay. Now consider that I have a circle. Now I am talking about 2D, x-axis and y-axis. 2D, x-axis, y-axis. There is a circle. Okay, so there is a circle centered at the origin. So there is a circle. If this is the center, then centered at the origin there is a circle where radius is a. What is the equation of the circle? X square plus y square equal to a square. If I if I have a circle like this, centered at origin, if there is any point here that is x comma y, then position vector is xi plus yj. Things will be more clear here. Xi plus yj. This is position vector. Then what is gradient of this vector? So position vector is xi plus yj. The gradient of this vector, since there is only one independent component x, y is dependent upon x. So there is one gradient is possible, that is dp by dx. So dp by dx is I plus dy by dx j. I plus dy by dx j, that is dp by dx. If that is the case, then what is I? Y. Y is nothing but square root of a square minus x square. So dp by dx, this is also called velocity vector. dp by dx equal to I vector plus dy by dx. So dy by dx is minus x divided by square root of a square minus x square j. So this is dp by dx. This is the kind of gradient. Dp by dx means gradient in dependent and independent plane. So if it is x-axis, this is y-axis. In xy plane, this is xy plane, in dp by dx would vary. That is I plus dy by dx j. So if I take a circle and if I take along x-axis, then here dy by dx is infinite. dy by dx is minus x divided by square root of a square minus x square. If x is a, it is infinite. Means at that moment the dp by dx velocity vector is along the j-axis only, because I plus I is negligible there. Similarly, on y-axis, dp by dx, dy by dx will be 0. dy by dx is minus x divided by square root of a square minus x square. X is 0, means it is 0. Only I component will be there. So here again it is tangential. Okay, so this proves that dp by dx, it varies like as a tangent to the circle, but this variation dancing happens in only YZ plane. If this is X axis, this is Y axis, this dancing, changing of this direction of this gradient of position vector or velocity vector, it is happening only in XY plane. Okay, if you are very right, I agree with you that you are very right. I agree with you. You are very right. Then can you please tell me what is parameter of this circle? We'll try. When I promise that if this is the velocity vector, if this is the velocity vector and velocity arc vector, because this is along the arc, right? Dp by dx is moving along the arc, means this is along the arc. This is position vector, radial vector, but dp by dx is moving along the arc. So if I have this velocity, what I want is this dp by dx, whatever is coming, if it is along the arc, then its magnitude, but it is velocity vector. To get the magnitude, I have to do dp by dx and then integration over x-axis, only one independent. Or in 3D, integration over xy plane, because xy plane was independent. Here x-axis is independent. So dp by dx, dp by dx. So dp by dx and then integration with dx. Anyway, it will bring p1. This is what we want, the arc length. So dp by dx integration with dx, and integration is full over the arc. So dp by dx is 1 dp by dx magnitude, means dp by dx, the we cannot do calculus on vector. Calculus is a game of algebra. So dp by dx magnitude dx. So dp by dx magnitude is dp by dx is I plus a by I plus minus x by square root of a square minus x square j. Its magnitude is 1 square plus x square divided by a square minus x square whole root. This will settle down in a by square root of a square minus x square dx. A I can keep outside. Integration of 1 by square root of a square minus x square would land up in sine inverse x by a. Okay, so sine inverse x by a. Now limit of x is minus a to a. So sine inverse x by a minus a to a. So a, if it comes, sine inverse of 1 is pi by 2 minus sine inverse of minus 1 is minus pi by 2. It will settle in pi. A outside, pi a is the circumference of a circle. But since we have centered it at the origin and xy we have taken in the upper half, so full circle will be double of it. So perimeter is 2 pi a. Proved, right? So this fundamental is correct, that if I have a position vector and if I calculate gradient of a position vector along a direction, and then if I calculate the magnitude and do the integration over the independent component, it gives me the length. If it is 3D, then I have to do cross product and then calculate the magnitude and integrate with the xy plane, then it will give me the area if I calculate the magnitude. Otherwise, area position vector. First area velocity vector, and then if you integrate with dxy plane, it will give area for the area position vector. Dot product with the vector field capital F and then integration over the surface will give the flux. We will talk about it more, because if you crack dA vector, then you crack flux. This is commercial calculus. We have landed from the curl, calculating curl itself, we have landed in commercial calculus, surface integral. So dA vector, we'll take one small example, then we will see. Okay, now consider there is a cylinder. Consider there is a cylinder. This cylinder is kept at the xy plane, where z axis is at the center of the cylinder. So this surface that is circular, there is a hole. Can you see? So this hole is origin. So this hole is origin. Now straightforward. X-axis, x-axis, y-axis, whatever. It is cylindrical coordinate system. So this is radius, and radius rotates 2 pi degree. and this is z value. Now what is vector field? Vector field is yj. This is famous example. So if it is kept like this on xy plane, vector field is yj along y direction, yj. Now calculate the flux. Flux is capital F dot dA vector integral over the surface. Consider this surface is only 0 to, only I am taking where x and y are positive. If it is kept at xy plane centered at the origin, it has 4 quadrants. I take only first quadrant where x and y are positive. Now what is the surface integral? Capital F dot dA vector. Capital F is yj dot dA vector. dA vector of cylindrical coordinate system is cos I plus sin j, then dA, that is r d theta dz. So cos I is gone because it is yj. So yj and sin theta j, they will do dot product and it become y sin theta. Y sin theta y sin theta dA. dA is r d theta, where r is the radius, or rather we can say a. A is the radius. So a d theta dz. Now here it is y sin theta, a dA y sin theta, and then dA is replaced by a d theta dz. Now y component in cylindrical coordinate system is a sin theta. So a sin theta multiplied by sin theta, a sin theta multiplied by sin theta, and then a again d theta dz. So a square sin square theta d theta dz. Now a take outside. Now integration of theta is 0 to pi by 2 because it will not be 2 pi. I have taken first quadrant only. So it is now 0 to pi by 2 sine square theta d theta. Whatever it comes integration, and dz is integration will come as z, whatever height I have taken. If I take 0 to 1, then 0 to 1. So a square 0 to 1, 0 to pi by 2 sine square theta d theta dz. Okay, so this would be the flux. Keep calculating it. We will see it, and then we will see if it is really thrilling and exciting. We will see more in dA vector before proceeding it to the divergence. That is the main thing. Amazing, very, very beautiful divergence. So that we will see.